Okay, so we have 3 muscle cells here. So can you guys tell me the difference between these 3 muscle cells and which ones they are? How can you determine the difference? Then tell me some functions.
There's a stationary, the cardiac muscle, and the smooth muscle.
So can you repeat that one? You said stationary?
Yes, or yes.
Are you sure it's stationary?
Oh, no, sorry.
But you're right, it starts with an S.
Skeletal.
Skeletal. Okay, so the skeletal. So tell me about the skeletal. What is its function, and then how can you distinguish which one is it? So we said we have skeletal, smooth. Can you guys see my screen?
Yes.
What do you guys see?
It does like your facial expressions, posture, voluntary movements, makes those possible.
So the skeletal. So which one is the skeletal? A, B, or C?
The first one?
Yeah. And how can we distinguish between that?
The lines on it.
The lines. So the fact that it's striated, right? And then also there's one other thing.
Those dark little pigmenty circles.
These guys here?
Yeah.
What are these guys?
The nucleus?
The nucleus, right? So they're the nucleus of the cells, right? We know that their skeletal muscle is multinucleated, right? Yes, no, maybe?
Yes.
Yes.
Okay. So, and like you said, this is for our voluntary movement. Anything else? Nelly had a song that could help with this.
Is it that it can help generate heat?
Right. So heat regulation
For
right?
thermal homeostasis.
That's right. Love that, thermal homeostasis. Excellent. I'm gonna have to use that one on the exam. It's a nice one.
Some residential.
Was it on that little paragraph?
Well, I have my book up.
Oh.
I'm reading from the book while he's doing his thing, which any of us could really do that, honestly.
Good job.
Thank you.
Okay.
Oh, whoops. My bad.
So now the B is what?
Smooth muscle.
So what is one way that we can distinguish between B and let's say the smooth and the skeletal muscle?
One appears to be smooth. It actually does look smooth, and the other one looks more rough.
Okay, so one looks smooth. Okay, what makes it look smooth to you? Just curious.
It doesn't like have the indentions like the other ones kind of do.
So it doesn't have the stratiate. It's not stratiated, right? Lack of stratiation. You don't see them, right?
Yeah.
You don't see these white lines and all that stuff. Okay, sounds good. The other thing is if you really look at this guy has that's one cell here. This is another cell here. This is a cell here. This is a cell here. So it's not multinucleated. Where we saw the cells are literally multinucleated. They have a lot of nucleates. And they just happen to border on the side of the thing, right? So what is smooth muscle for? I'm sorry, that isn't even smooth muscle. Oh, it is the smooth muscle, sorry. What is smooth muscle for? So if this guy was for a voluntary movement, what do you think smooth muscle must be for?
The book says that it,
Involuntary?
yeah.
Involuntary. And you said the book says what?
It says involuntary movements and the internal organs.
Okay. And that kind of makes sense because do you control your organs?
No. Well, in a way. Not with, my,
Do you say, okay, breathe, right?
yeah,
And
I
you're-
don't tell myself to do it. It just does it.
Okay. So, involuntary movement. It's Monday. Okay. And so we know that these are also involved in regulating like flow in the arteries and stuff like that as well too. So because all of that is part of that involuntary, right? So we don't have to specify. Okay, what about cardiac muscle? So by default,
Forms the walls of the heart.
that's our heart muscle, right? Cardiac, heart. And its job is, like you said, it's forming the walls of the heart, responsible for the pumping of the blood, right? Pumping to the heart. Questions, concerns, cash. Simple. And you can see here, again, single nucleated cells, right? But it's also stratiated. These guys are going to be short, short stratiated cells, like shorter compared to these long fibrous structures. Okay. Questions, concerns, cash. No questions, no concerns, no cash.
No.
Okay, good. Okay, so this here, excuse me, this here is a neuron. So in the neuron, you can kind of see how you have your axius and you have your dendrites that are just kind of protruding from it structurally, right? Here, I'm sorry, your axon, not your axius, your axon. And so your axon is just basically, it's like a long passageway that's going to be basically used to carry potential that's away from the cell itself, right? So this is your control center. This is kind of like a passageway to sit there and provide that impulse. So you're just going to be sending impulse down this pathway, right? And so this guy is going to contact other cells. Your dendrites are also responsible for making contact with cells that are around it. And then, of course, you have your nucleus, which is going to be kind of controlling that process. Okay. So if you look here, So this basically here is a neuron cell, and you can kind of see, and you can see that long axis going along here. Can you guys see that?
Yeah.
Same thing over here. And then you can kind of see the axis in that area. Can you guys see that?
Yeah.
Okay. So now the body of your neuron, this part here, this guy is called the stroma. This is where your mitochondria, so all of the energy producing parts of it is going to be here. And then you also have your nucleus, your control center, right? So you have your energy producer and your control happening here. Down here, this is, like I said, it's just for signal. So we're going to be using this aspect for signal. So this guy's called stroma. That's called the axon. And so you're going to be sending an energy potential along this axis. And so that's why you have this long, narrow path, because it's just going to be used as a signaling cascade down there. Okay. Now, excuse me. So this is the makeup of nervous tissue, right? So we have neurons and we have the neuroganglia, right? That are going to be composed up of our nervous tissues, right? So one, their neuron is going to be responsible for the transmission. The neuroganglia is going to be responsible for receiving, okay? So these guys, astrocytes, our microglia cells. So those guys are going to be responsible for, they're the neuroganglia, right? So they're going to be receiving this. So these guys are going to be making contact with them, letting them know, hey, what's going on. Here we have what we call the myeloid sheet. So these are just basically proteins that are surrounding the potential. And it's kind of like a kind of conductive material, or not conductive, an insulating material, sorry. And so its job is to basically kind of protect the potential that's going through. So you're not losing it out to the structure, and it's going to where it needs to go, okay? So that sheet is kind of acting like an insulator to kind of protect that. So kind of like, have any of you guys did any electricity, or have seen anybody do any electricity, or went to Home Depot? And if you actually look at wire, right? So the metal part of it is on the inside. On the outside, we have insulation, right? So the myeloid sheet is kind of like that insulative component, okay? Are you with me so far?
Yes.
Yes.
Okay. So our neuron is kind of like acting like that wire, right? It's sending that electricity, or sending that signal down there, okay? And so we want to make sure that signal isn't dampened or anything like that. It gets the most of it. Now, if we have exposure along the way, we could lose some of that signal to that environment. And we don't want that to happen. We want to make sure that it goes where it's supposed to go. Okay. Make sense?
Yes.
Yes.
Okay. So if you guys look at the astrocytes, right? So these guys are going to be kind of like the most abundant ones. They're kind of star-shaped. They have the dendritic dendrites on it as well too. So you know that they're going to be involved in that kind of touching and feeling, that connection, right? So these guys are going to be they're going to be picking up those impulses, right? And so that's what the dendrites are there for. They want to make sure that there's that contact, making sure that they're able to get those impulses that they're supposed to get. Okay. They're called astro because they kind of look like stars, right? And if you look at it, astrology, right? Stars. Okay. Okay, so that word ganglia, that basically means like glue, adhesion, kind of sticky, glue-like structures, right? And because you have the dendrites that are kind of attaching and they kind of weave together, kind of like if you look at them, they kind of look like roots in a way, right? You guys seen roots to a plant, and when it kind of weaves in itself, so you have that attachment, and it's hard to separate one root from the other because it kind of branches into each other. Yes, no, maybe.
Yes.
Yes.
Okay, so that's exactly what's happening in this situation. And so a lot of these structures are going to be those contacts that are going to be forming. And if you look at it, I mean, the histology is kind of hard to see, right? So right now you can see these guys are the neurons, and you can see the axons going down here, neurons, and axons going along the way. And then you know that these cells that are surrounding it are the astrocytes that are also kind of very fibrous. If we took a closer look, we can kind of see those fibers forming. Okay. So the oligo dendroid site, these guys are responsible for making the myeloid sheets. That's their basic primary function. And so all they do is basically make the myeloid sheets for the axons to kind of protect that potential, that inflammation. Okay.
Okay.
So let's kind of write that up. Sorry, myelin, not myeloid, myelin sheets. These guys are going to be receiving. Okay. Questions, concerns, Cash, simple. So the nervous tissue is kind of real simple, right? So we know exactly what it's there for, right? It's going to be sending those signals to tell our nerves what to do. Hey, move your hand, right? It's hot. It's going to be, okay. Make sense?
Yes.
Yes.
Okay. Making sure. I like it when it makes sense. Okay, so the next part is that really is a part of this process. It's actually it's repair, right? Wound repair. Okay, so let's say you cut yourself, cut your finger, you get a scratch or something along those lines. So the first thing that's going to happen is that we're going to start clotting, right? And so your clotting proteins are going to be produced, they're going to be secreted, and then a lot of your plasma proteins are going to sit there, and it's going to form what we call our scab, right? So we're going to then send from our cells, we're going to get inflammation. So it's going to swell, it's going to turn red, that wound is going to, and so what we see is that red part, but what's happening is that we're sending chemicals to say, hey, we have an injury. We need to make sure that this guy gets fixed. Okay. So then after that, we have macrophages, which is going to be there for kind of protecting. So it's their job is to say, well, if we're getting some inflammation, is this inflammation coming from a source that we don't want, right? Part of it is that wound, a result of something that happened that we don't want. So then the macrophages are gonna make their way there. They're gonna start doing their job, right? In the sense of they're gonna start eating up stuff and breaking down stuff, bulking things to make sure that you're not, to protect you from that potential infection, okay? And then you also have just generally your white blood cells that are also gonna be involved in this process as well for protective purposes, to try to, get rid of that infection, right? So then once your cells, your fibroblasts, your macrophages, and then your tissue basically starts repairing itself, starts healing itself, okay? So then your scabbing and stuff like that, that's gonna start dissolving, starts to fade away. Eventually, you notice how your scab falls off, or we get anxious and we pull it off, one or the other, right? So these guys, the tissue itself will start healing and I guess maturing in a sense, and then eventually that scab is removed. The problem is that often we will have what we call all of this here, which is just our scar tissue, right? And so that scar tissue, and that's, again, is composed of cells themselves, fibroblasts, things like that, that remains until it's kind of broken down, right? So have you guys had a cut before? And let me see if I can find mine. I have one on my leg that I would normally show in class, but it'd be kind of weird me lifting up my leg and showing my big old scar, right? So do you guys, any of you guys have a scar?
Yes.
Okay.
Yeah.
Have you, like, if you run your hand across that scar, how does it feel?
Well, because it's old, it's still smooth now, but a little bumpy on certain ones.
Yeah. Okay. So it's a little bit rough on the recent one. And if you didn't like, the doctor would always tell me afterwards, hey, you need to massage it, because I have a really big scar because I did stupid stuff when I was in high school. Got in trouble and did some stupid stuff. So I have a really nice cut that's about this big on my leg, and so I'd have to get stitched. So because of that, I had this nice scar, and I never like rubbed it or anything like that, because I thought it was really weird, to be rubbing your leg and all that stuff. That's kind of weird. So, being a boy and being worried about what everybody else thought, I would never rub my leg. And as a result of it, my scar is really firm and hard and stuff like that, because it just kept that scar tissue, right? And so that scar tissue can remain. And so that can cause a lot of damage to the neuron as well, because it's scar tissue, right? It's that tissue that is just, it's basically there for repair. So you're going to have collagen fibers, you're going to have your fibroblasts, and all those things are there, but eventually those things are going to die, but they die there and they're not decaying the way that they should, and you're not helping getting them out by that subtle massaging. And as a result, you get that nice scar that forms there, and it's elevated and heavy and things like that. And that's just because.
So for a diabetic patient, why is it a little bit more harder for them to heal over a cut, or like a cut?
Yeah, part of it is it's harder for them to heal over a cut, is because so in terms of diabetes, right, it regulates your sugar levels and things like that, but it also, because of that, is a form of regulation, right?
Mm-hmm.
That means that you're also not getting the appropriate nutrients to certain sites, because the signals are not going the way that they're supposed to, because your blood sugar is supposed to be regulated, right? So if you're not getting enough blood sugar, if you're not having enough sugar in your blood, that's going to cause some issues, right? Because sugar is how we generate and how we solve things, right? So you're not giving, first off, you're not getting the signals that you're supposed to, because that's what's part of the issues. The second part of it is that you're not getting the energy that is supposed to be out. So does that make sense? Like, because you're not getting enough energy, so it's not healing the way it's supposed to. You're not forming the structures the way you're supposed to, because there's not enough energy there to do it.
Okay.
Okay.
So that's why with the diabetic patients, they always tell them you need to be moving around so they can get that blood flowing and
that's right.
kind of getting that exercise going.
Yep. Those are good questions.
Would you say it's similar to like smokers, because people that smoke, they heal slower as well?
That's true. And then that's because it's similar, but it's similar in a lot of ways, because again, affecting those signaling cascades, those pathways, right? And so you'll also often with certain drug users as well, you have certain ones that will that are overstimulated. So they overstimulate things, and so they heal too fast. They heal faster than what they should. So there'll be some internal damages that are not completely healed, but on the surface they'll be healed. Do you know what I'm saying? And so you have, let's say, a drug user, particularly like meth. Meth has a tendency of overstimulation, right? So a surface wound will be healed all smooth and everything like that, but underneath you'll still have tissue damage because you haven't provided enough of those cells didn't have enough time to get there and do what they're supposed to, but you have signals that are saying, hey, go ahead and start healing, right? And so, but like a smoker, in that case, we have things that are being toned down. So you're impeding those signals. And so they're not developing the way that they should, right? So in that case, it's taking forever for them to heal compared to somebody who doesn't. And it's kind of cool if you start thinking about this and how it all plays a part in this process, right? Because part of this process is the way that we get rid of these cells and stuff that are part of this this tissue after it's healed is a process called apoptosis. Apoptosis is programmed cell death, right? And so you're supposed to go in, do what you're supposed to do, and then those cells kind of kill themselves. And then after they kill themselves, they're supposed to break down and all that stuff. And so that gets all kind of cleaned up over time. And the debris and stuff like that gets moved. And so you kind of get rid of the scar tissue and things like that because you're constantly moving or doing what you're supposed to do, rubbing those tissues. And so that is a vital part of the healing process as well, too. And so if those aspects are getting screwed up too, that can also cause problems. The other thing is necrosis. Necrosis is another form of cell death, but that one is a result of inflammation, right? So just the fact that you're producing more inflammatory conditions, you're causing cells to die as a result of that, right? So you've heard of necrotic tissue. You have excess necrotic tissue or anything like that. You've heard on the TV shows or yes, no, maybe?
I want to say yes.
Maybe.
Okay.
Does
So
that have something to do with death?
yeah, well, yeah. Necrosis is death, right?
I
But
think
it's
necro and then I think death. So
yes, like necromancer. Yes, let me write both of those terms there. So we have necrosis. So this is like accidental death. But it also can be a result of those inflammation signals, right? So necrosis can result from cells around it said, hey, you're inflamed, we have an infection, so we want to kill you right now, okay? So accidental or okay, and then we have apoptosis. So in theory, we want apoptosis to be what we want, that death, right? Necrosis, I mean, we need that necrotic aspect of things because if we don't have it, we couldn't respond to things immediately, right? Because then everything would have to wait till that programmed cell death occurred, right? But apoptosis is programmed cell death. So cells will live for so long, it'll divide, live for so long, and then finally they die out. That's one aspect of apoptosis. The other aspect of apoptosis, cells that have defined lifespan. So like the cells that are going to be involved in your scarring tissue, right? So those cells, their job is to sit there and form that scar, right? To allow everything to kind of mend, to get together, to do what it's supposed to do. And then eventually they die out, and then it's just that scar, right? And so eventually then those cells are going to be, that debris is going to be broken down, and then those parts are going to be mended together eventually, you know, in theory, right? So we need both aspects. They're both necessary. Apoptosis is the one that's, as I said, it's controlled, right? And so we definitely want that. So sometimes what we have is cells that are just acting to responses, necrotic tissue, right? So then in that case, you have tissue that is all dying, that's not supposed to be dying, right? And then, so it's out of control, it's lost control of that. And so part of this process is that signaling. We have those inflammation signals that are responsible for it. We have signaling internally as well that is also going to be responsible for it, saying, hey, you know, this is happening with us internally, so we really need to die, right? And then sometimes those cells themselves will signal cells around them, because then they'll start causing no cells around them to die when they lose control. So this has to be a highly regulated process. So like, have any of you guys been bitten by a spider? So like the brown recluse spider. You guys have heard of that before? Right?
Yeah.
So one thing that spider does, it actually, the venom in the spider, there's proteins in that venom that causes cell death, right? It causes that necrosis. It also provides you, there's a bacterial infection that occurs with it too, right? So the spider itself carries certain bacteria, and you get that bacterial infection. Well, you're also killing those cells around it. So the brown recluse is also known for causing high levels of necrosis because of the combination of the strep that's there and also the proteins that are in the venom. So it kind of sets up that area that it kills. The bacteria plays a part in the spider's, I guess, life cycle, in a sense that it helps kill the thing that it's after. So the bacteria plays its part, but the venom also causes the cell death around it to make that tissue a little bit easier for those fangs to get in there and then get the blood that it wants, right? Because primarily spiders are kind of like vampires. They want the meal. The meal of it is the blood, you know, that's giving it what it's looking for. Okay. And so it causes necrosis of the tissue. So when the spider bites you, right, with its venom, it's giving you both the combination of the bacterial infection, and also the proteins are also causing the necrosis of your epithelial layer to make it easier for it to get to where it wants to be and get the blood that it needs, right? It's not necessarily intentional for you, but it's like for its victim in general. Does that make sense?
Mm-hmm.
Okay. And so in that case, it's using a protein that's involved, that is very similar to the proteins that are in your body, that is involved for inflammation, right? Sending those signals to cause that necrosis. Okay, so let's see. So cancer. So what is cancer?
I remember you said something about like overactive, like whenever too many cells are being produced at once and it's just a bunch of them start to clump together and create a tumor or a mass.
That's right. So exactly. So cancer is when our cells kind of lose control of their cell cycle or cell division. Okay. So in this case, their cells are growing way too fast. So if the cell is growing way too fast, that'll also start affecting our cell size and how these cells are interacting with each other, right? It'll affect tissue organization, adherence molecules, things like that. So, so in the case of cancer cells, we can affect the size of the cell. The cells are typically going to be smaller than what they're supposed to be because they're dividing way too fast, right? So they're going through their division process. They're not making enough nutrients and stuff like that. They're also, in a way, immature. So they're not making the necessary adhesion molecules. So they're not sending out those things to say, okay, we need to stick together to form that tissue. So if it's not, the tissue is not forming, you're getting mass formed, but the tissue is not forming the way it's supposed to. It's not sticking the way it's supposed to. What's going to happen to that tissue over time?
Gonna break off and into other parts of the body.
It's going to break off. And that process of it breaking off is called what? Do you guys remember?
Ooh, I don't. Is it the C word?
No, it starts with an N. Carcinoma is just a general term. That's the one that everybody
Okay.
thinks is carcinoma. So it's not carcinoma. It starts with an M, meta something. Metastasis, you've heard of that before?
Yeah, kind of a little bit.
So in other words, you're saying that part of the cell has broken off and moved to another tissue, right? So the cancer metastasizes, right? So basically it transferred itself from one tissue to another tissue. So now that tissue, that little piece of tissue is going to start growing in there. So it's going to have that original function. So let's say it was a breast tumor, right? And it metastasizes, then it goes to your lung, right? You said the cancer cells metastasize in your lung now, right? So what that meant was that breast tissue broke off, and those cells, right, that clump of cells, that tissue there was transferred to your lung tissue, and it attached to your lung tissue, and it started growing there. And so it starts telling the lung tissue, hey, dude, you're really breast tissue, right? And you're around me. And so the lung tissue is getting mixed signals. So that environment becomes a little microenvironment within the lung tissue. And so those cells get confused because it's getting signals that it's not supposed to get, right? Because lung is not breast tissue, right? They're two different tissues. And so it's sending all the wrong signals. And then the lung is like, wait a minute, who am I? And it starts losing track of who it is. And so gradually it starts to sit there and make changes because it's getting, on one side is getting lung signals, and on the other side is getting breast signals. And so it's like, who am I? What am I? And so those cells, when they start to divide, they get confused. And then that changes that environment entirely. So that environment becomes kind of like hybridized in a sense, right? And not only that, it's sending out wrong signals in the first place because it's out of control, sending them out way too early, way too fast, and the cells are getting smaller. And that's affecting those cells too. Okay, so then it starts affecting that cell's growth, right? So that little bit of tissue goes there, kind of invades, and it keeps growing, but it's also affecting the cells around it as well too. So those are called microenvironments. Now, that regulation, because that regulation is out of control, it's causing severe issues. And it also changes the tissue organization. Does that make sense?
Yeah, it sounds like a really bad relationship.
Yeah, exactly. Exactly. Yeah, very destructive, right? You get that bad boy that, tells you, you're not worth anything and stuff like that. And then you start thinking, I'm not worth anything. I can't do anything. I don't do anything right, right? It's exactly the same way.
They could make a really funny episode of Rick and Morty with
Yeah.
that whole scenario.
Yeah. There's one other thing that I wanted to talk about. Just aging. Okay. So we age, right? We can't avoid it as much as we're trying to. What is that magic pill to keep us from aging, right? And part of aging is just the loss of fluids in general, right? So we start to get those wrinkles in the bags and stuff like that. So over time, our body isn't retaining the fluids that we're supposed to. That's why there's like drink water, drink water, drink water. I'm horrible at drinking water. For some reason, the older we get, the less water we want to drink. It's like I would prefer drinking the alcohol, right, than drinking the water, which helps dehydrate me. Or I prefer drinking the coffee, which helps me up, that dehydrates me. But partially what goes on is over time, our cells don't retain as much fluid as they're supposed to, because that control starts to lose. We're not controlling things as well as we should, right? So part of that desire not to drink water is a result of your cells aging, right? And the fact that you're not replacing them the way that you did when you were younger. And so that's a process. Cell aging is a process, and it's something that's on the cellular level as well as the chromosomal level. So the chromosomes, they're aging, so they're actually shrinking in size. So there's these what we call telomeres, right? So there's this protein called telomerase, and telomerase normally puts extra sequences at the end of your chromosomes so that you don't lose any DNA sequence, things that are valuable, right? But what happens over time is that those telomeres start to shorten and shorten and shorten and shorten, and eventually you start losing some of that DNA, or it causes sites where you get more mutations. So resulting in cancer development and stuff like that. So it's it's a thing that plays on itself, and some of those things are affected by the environment, the loss of water. A lot of these factors kind of they feed into each other, right? Because that polymerization and breaking down is a result of water, right? We know that dehydration helps with synthesis, and then hydrolysis helps with breaking things down, right? Remember that. So all of that kind of plays, and there has to be a nice tight balance for things to happen. And as we age, we start affecting that balance by those environmental factors, by those social factors, by, it's like, God, I need my beer every night, or God, it's been a rough day in class. I need to have a glass of wine, otherwise I can't grade these tests, right? So all of these factors will play a part in that process. So it also plays a part in the homeostasis, right? And again, we go back to that term. Homeostasis is getting that balance, having that balance. So we're putting factors environmentally or socially into that balance. Stress. How many of you guys stress out? You stress out about exams?
Yes, all the time.
Yeah, all the time, right? So stress, oh my gosh, it is huge, right? And so like before, we just stress out about an animal trying to eat us or something like that. Now we stress out about, oh, my exam, and oh, my kids, or, oh, my boyfriend, my abusive boyfriend, so we no longer worry about the animals kind of getting us. We worry about other things. And so those are other signals that are being generated in our body that are also causing these things to happen. Loss of water. What happens when you stress out, Leticia?
All kinds of things. You can have hair loss, weight gain.
Yeah. Ever since I started school, I got fatter, right? And
weight loss and weight gain.
Weight loss or weight gain, yeah, or a combination of both. Some people go through both, right? Different stages. It's like,
Acne.
okay, acne, yes. And I break out like crazy when I'm like under a lot of stress, right? It's like I've been eating chocolate all day, which probably happens too. So
Sleepless nights.
Last night, right? I have 50 million things I need to get done and don't want to do any of them, but I have to try to get something done. So these are all signals that are going to be sent out, right? And they're all controlled by our bodies. If these signals aren't controlled, we get things out of control, out of whack. And so our body's trying to find ways to make it better. Your body's trying to let you know, hey, dude, you need some sleep, And then eventually your body says, okay, you're not listening, so I'm going to shut down, right? And then it kind of takes control. And so you'll start having medical issues and things like that, where you went from insomnia, where you can't sleep at all, and now you're like, I can't get up, I can't stay awake because you're so tired, right? Your body just says, okay, we've had enough, we're going to start shutting down. Okay. So this is going to be controlled at multiple levels. They're controlled at the chemical level, they're going to be controlled at the tissue level, and they're going to be controlled at the say system or organ level as well too, right? So You guys are you starting to see how it all kind of plays into each other? Yes, maybe.
Yes.
Yeah, how it all connects.
Okay. So aging and tissues, right? So if we think about aging, when you're young, you could eat chocolate every day for weeks and weeks and weeks. I mean, you get a little fat, right? And stuff like that. But you really didn't have issues with heart disease or, and if you did, it was like you'd have to be extreme, right? As a kid and literally eat chocolate with every meal, every day, all the time, right? And or diabetes or but as you got older, you can't eat the way you ate when you were a kid. Like I love Popeye's chicken. My God, I love Popeye's chicken, right? But I know if I try to eat Popeye's chicken every day of the week, right, my arteries literally start hurting, right? Physically hurting. And, when I'm eating, I can hear myself breathing harder and stuff like that, right? Because my body doesn't process that food anymore. It doesn't process all that grease the way it did when I was, 18 and 17. Where when I was younger, I could sit there, I would go chicken every day, after I left home, I would literally go, there's this chicken place in Santa Barbara, UC Santa Barbara in my first year of college. And my mom would always save me some extra cash because at the time, as a long story, but at the time, my financial aid didn't go through. So my parents were sending me money for food and stuff like that. I couldn't get food from the dorms because I didn't have enough money to pay for the meal tickets. So I would eat out all the time. And I actually had a car. So, where I would just take bus downtown and then I'd go to this chicken place and buy chicken for the whole week, right? So I'd buy it because they had a really, really good deal. If you got there on Tuesdays, you could get was it 20 piece for like $20 or something like that, or $15 or something. It was a really good deal. So I'd get all this chicken. I had a little refrigerator in my room. So I'd stick my chicken in there and I'd eat fried chicken every day. Right? And, of course, I got fat. I got a little bit fatter because as a result of that. And then also the stress. But ultimately, I wasn't like having trouble breathing and my blood didn't feel like it was having a hard time flowing. Where now, if I do that consistently, I end up having to go to the doctor and say, I have high blood pressure, I have this and I have that, right? So
Yes.
my point is that over time, our bodies, our tissues don't heal the way that they're supposed to, right? And that's all of our tissues. And they're slower at healing. They're slower at doing things. And also that cell replacement isn't happening the way that it should. And all of that is kind of controlled. And over time, we start losing more and more of that control, especially, again, environmental factors, all the greasy foods and all those things. All those things play a huge part in that process. It tastes so good, you don't want to give it up, right? You guys have a vice that tastes so good that you don't want to give up?
Yeah.
Yeah.
It's like the hot Cheetos.
Hot Cheetos.
That's what I was
Yeah.
gonna say. It's hot fries. Those hot fries though. I can't even eat them no more.
Yeah.
I can't even eat that green enchilada sauce anymore. Oh, it makes me so sad every time I eat it. I get super sick now for some reason.
Yeah.
Because you still have that memory of how it made you feel when you ate it.
Yeah. Exactly. Yeah. And so the other term that I want to talk about is atrophy, right? So if you don't do things, right, our muscles go through atrophy, right? So then they lose their mass. And part of that is the loss of water, also loss of protein, right? So that protein is being broken down. We're utilizing it because we're breaking it down like crazy to kind of compensate for the fact that we're not doing those things that we need to do, right? So I could just imagine like I got a lot more fat, but I have a lot of atrophy in my legs and stuff because I don't use them the way I used to because I'm sitting at a desk all day long, right? 8 o'clock in the morning till 10 o'clock at night, I'm at a desk. So, and so that's not healthy as well too, right? And so that's an example of tissue going through a process of breaking down, particularly muscle tissue in this case, right? Make sense?
Yes.
Yep.
Yes.
And then how many of you guys are getting arthritic? your joints hurt, you know.
Me?
Yeah,
Me?
when it gets cold, right? And you're like, oh, and you can't bend down the way you used to bend down, right?
Yes.
Yeah.
A lot of that is
Like
because
26.
we've lost that cartilage, or we have fibers that are generating that aren't supposed to be there, that that are growing where they're not supposed to grow anymore, right? Because we've lost control of that tissue growth, right? So is that good? You guys have a good understanding of everything?
Yes.
Yes.
Okay. So that brings us to chapter 5. See how we do on time. How about we save chapter 5 for Wednesday? Is that cool with you guys?
Yeah.
Yeah.
So chapter 5 is the skin. Okay. So the integumentary system. So we're going to be talking about that, and also mostly there's a lot of structures in it. We're not going to be so focused on the structures. There are going to be some superficial aspects of the structures that we want to talk about to kind of give us points of that regulation. Okay. But we're going to be focusing primarily on the regulation of the skin. We know what it primarily is for, right?
Yes, to protect.
For protection. Also,
Hold all your organs.
again, protection, hold all your organs, keep keep everything in place. Anything else? Think about some of the things that we've talked about, some of the glands, and what are some of the glands that we have in our skin cells, or in our skin tissue?
Is it like maybe help our body to do certain things, like for example, when you said we get hurt, our body starts to do certain things?
Yeah. So yeah, again, it deals with that protective aspect. So we use some of those things for protection. True. Anything else? Any glands that you think about? Gland, because think about your skin, right? What does your skin do? On hot days, what happens?
The temperature, control of temperature.
Yes. So one of the major things that it does, your skin is responsible for, is temperature control, right? Because you have all your sweat glands in your skin, right? So it helps control your body. Yep. Thermoregulation, right? And let's say we've talked about sort of acne and stuff like that. Have we talked about that?
Yes, a little bit.
Yeah.
Well, with stress.
With stress, yeah. We talked about it in terms of stress, right? We get our pimples and stuff like that. But it also, look at our skin. I mean, if you feel your skin, let's say around your nose area and stuff like that, and a lot of us who are, older and stuff like that, particularly around our noses and around our ears or in this area, right? What do you feel when you rub your hands on your skin?
Sometimes pores.
Pores, okay. Anything else? Why do we a lot of times what was that?
Oils?
Oils, right? Oils. So why do we need oils there? Why do we need?
Hydrate your skin.
It's also a way of protecting the fluids, right? We don't want to be losing any fluids that we're not supposed to. So the oils are kind of there to, in a sense, kind of clog and help protect, some of those fluids.
Saying is that it's good to have oily skin.
to some extent, right? Sometimes we get excessive, right? So like when you're going through puberty and stuff like that, you have too much oily skin. And that's how you get those pimples formed, because then your oil is not, it's not being released the way it should be naturally. So the pore itself gets clogged. And so it's clogged with the oil, and then you just start getting more and more and more and more. And then you pop your pimple, and then you've released all of those oils, right?
So this might be a little bit off topic, but I work I work in the, I take care of people that are sickly, and so we have to wear masks all the time. Like I'm wearing a mask more than I'm not wearing a mask
Yeah.
since COVID started, and all of us, our faces are like really broken out, like so bad, and only around where you wear your mask.
That's
So I'm
right.
thinking like, oh my gosh, is it because we're our breath? Is it like the insides of our mouth bacteria is getting into our skin and we're just consistently
Yep.
causing infection in our skin?
So it's a combination. So you have a couple of things that are going on, right? So your body is it's producing those oils as a protective, right? So those oils serve two purposes. One thing is to kind of lubricate that area, but it's also to kind of protect you against those other things that are trying to invade. So it'll put a surface of oil on there to try to keep those bacteria from sticking around. And so it kind of just runs down. Eventually your sweat comes in and helps kind of cleans it up, right? So you guys are getting more bacteria, more exposure to the bacteria, like you said, from the mouth and things like that. And since you're recycling that whole process consistently, more and more exposure to those bacteria. So your body's producing more and more oils. So you're getting a combination of those bacteria that are sitting there, and you're trying to produce more oil. And so sometimes you're getting more oils that are clogging up those pores, as well as those bacteria that are sitting there too, that are kind of like, hey, we're here, we're going to stay here, we're not moving anywhere. And then if you notice, you'll probably sweat a little bit in that area too, right?
Oh yeah.
A lot more. So, but the thing is that it's just sitting there. You're not getting a chance to go and rinse it off daily and stuff like that. And you're also not getting exposure to the sun that will also kind of kill some of that bacteria. And then also it causes you to sweat a little bit more. So you kind of, you're flushing out those bacteria and some of the oils with it, right? So then as a result of it sitting there, you're going to break out more, right? Because it's just sitting there. It has nowhere to go. And so, yeah, it's same thing's happening to me. I notice when I have to wear a mask for, like, I have face-to-face classes occasionally, and when I wear it all day long, and I'm just like, it's horrible. Or my meetings that I can't get out of that are face-to-face. We had 3 days of interviews, and literally a mask from 8 o'clock in the morning to like 6 o'clock at night. And so then as a result of it, I break out really bad, Yeah, so same reason.
Yeah, and we're moving the clients a lot, so I'm sweating throughout my shift. And when we give them showers and stuff, oh my God.
Yep.
It's awful.
Yeah. No,
Imagine
that
wearing a
doesn't
mask
fit.
in the shower.
Yeah. And then also just I need to remind myself, because the masks themselves, they're fibers, right? And so they're collecting bacteria within them. And then with me putting spit and stuff in there, it's feeding some of those bacteria, right? So it keeps this bacteria around a lot longer. So I have to remind myself, hey, I need to wash my mask routinely, get in the habit of, okay, I wear it just for that day, and I should be wearing another one. So I have a lot of masks, but I have a bad habit of just waiting till I'm washing them all at once and stuff. So I need to get in the habit of washing them routinely.
Okay, so then it can be really beneficial to wash your mask or just
Yeah.
to get new ones
Yeah.
frequently.
Exactly. And that'll help out a lot too. So, okay.
Thank you.
Okay, so we're gonna stop here. So you guys, I will be putting up the lab, the physio lab, and again, it's gonna be dealing with one of the next two chapters. I believe it's the bones. So, because I don't think we have one for the skin, but I'm gonna try to see if I can find one for the skin first. So. I could be wrong, Jesse. You have that look like I'm wrong.
No.
Yeah.
Just listening.
Okay. Questions, concerns, Cash?
No.
Okay. So I'm gonna stop here, and then I will see you guys on Wednesday.